Okay, good morning to everyone. So we have been discussing motion in the plane, and we got to know that what is meant by motion and what is plane and how the motion will take when it is in two dimensions. So everything we have studied. So now the new concept here we have, which is projectile motion. Okay, so today's concept is projectile motion. So first of all, the motion means, already we have studied, motion is nothing but it is the process of changing the place. That is what we call motion, right? For example, if we have one body at this point, so after some time it will go to this point, this point, this point. It means in every situation it is changing its position. Okay, with respect to what? With respect to time. So this process is what we call motion. You just keep in your mind, motion is nothing but changing in position, right? The object changes its position in every situation with respect to time. That is what we call motion. Okay, but here we have projectile motion. So the first thing arises that what is meant by projectile. Okay, see, the projectile is nothing but whenever an object thrown in a space in the sense two-dimensional, so it is allowed to move under the action of gravity. That process what we call projectile. For example, consider two dimension. Here we have one is x-axis, another one is y-axis. This is what we call plane. Plane in the sense two-dimensional or two axis. So in this plane, if I throw any object from this point, right? If I throw any object, so what it does, it will go somewhere at this point. After that, what it does, again it goes back to the downward direction. The meaning is to say that whenever, or the simple example, so if you throw a ball, so at a certain height it will go. After that, what it does, again it comes back to the downward direction. The meaning is to say that it is coming downward because of gravity. Because of gravity. Right, in the same way here also, what I am doing, from this position I am throwing a ball. Right, here I am throwing a ball. So at a certain height it will go. After that, what it does, it goes to the downward direction. That is due to the gravity, right? And also in another way also we can define, that is a projectile. Projectile is nothing but whenever a body thrown in a space, it is allowed to move in the horizontal direction, right? You can see here, see, it is moving in this direction, that is in horizontal direction. And also here it is making an angle theta with this horizontal. So this what we call projectile. So many example you can give. Whenever a bomb released from the plane, so it is come to the downward direction, that is due to gravity. Or whenever if you throw any stone or ball, so after a certain height it comes back to the downward direction, that is due to gravity. So that what we call projectile. By taking this two-dimensional or two axis, we can define here. Right, projectile is nothing but whenever a body thrown, right? Whenever a body thrown, it makes an angle theta with this horizontal. As you can see here, it is making an angle theta with this horizontal. So this what we call projectile. And whatever the path here we have, right? The path followed by the projectile, that is what we call trajectory. Right, one more thing here I have to mention, that trajectory. Projectile means we have got to know that it is the making an angle with this horizontal. Right. So now trajectory. So trajectory means what? The path followed by the projectile. Right, as you can see, the path is in this way or in this situation, right? So this is what we call trajectory. and trajectory is always in the form of parabola. Parabola. Right. Trajectory is nothing but the path followed by projectile. The path followed by projectile is what we call trajectory. Trajectory is, you should keep in our mind, trajectory is nothing but it is a path followed by what? Projectile. And one more thing, it is always in parabola. It is always in the form of parabola. As you can see here, this is what we call parabola. Right, this portion is parabola. And you know very well the equation for the parabola is y is equals to ax plus bx square. Right, what was our concept? Projectile motion. Right, projectile, it is the making an angle theta with this horizontal whenever the object thrown in a space, that is projectile. And whatever the path followed by this projectile is called trajectory. Right, now we will derive the path for the projectile. I mean to say the trajectory of a projectile. Right, as we have defined here, it is parabola and equation is ax plus bx square. And we will derive in this manner only. It means we have to get the trajectory in such a way that in this equation, that is y is equals to ax plus bx square. In this form we need to get. Right. So now we will derive that portion. So yes, trajectory of a projectile. It means here we are going to derive the expression for trajectory of a projectile. Right. So for that purpose, projectile. See here. First I will take the two axes. Why? Because we are dealing with this projectile. Projectile needs two dimension. Right. See here. I will take a two axis or a space. One is x axis, another one is y axis. So now I will take an object from this point. Right, in that I am saying that I will throw an object from this origin O. Right, see, as you can see here while playing in ground, so if you throw any ball, it will go in this direction. Right, otherwise if you throw from this position to the upper side, so at a certain height it will go, after that again it comes to the downward direction. Right, when you are in this place, you are trying to move this ball to this direction, what you will do, you will throw like this. So after certain height it will go, after that the same distance it will cover. The meaning is to say that here we have to get the path, right, how it has been covered the path, that is a trajectory, right. So that we are going to derive here. See, from this point I will throw one object with initial velocity. Right, one thing you have to remember that, so whenever body it is moving, it will have the one quantity which is velocity. Right, see from this point I will throw an object with initial velocity u. See here. So it will take like this. Right. See here. Here I mean it is moving with initial velocity u. See, in the earlier classes we have studied that when the quantity is in two-dimensional, that covers two axes, that is x-axis and y-axis. And here also you can see here it is covering both y-axis and x-axis. Right? Actually the direction of the velocity is in this way, but after a certain height it will come to the downward direction. So now it will cover both y-axis and x-axis. So that's why we have to resolve the velocity into two components. Why we have to resolve the two components? Why? Because it is covering both y-axis and x-axis also. Right. It's simple. You can see initially the object is in this way. You can see it is covering this x-axis and y-axis also. So after some time it will come at this position. Here also it has been covered the x-axis and y-axis. It means in every situation it is covering x-axis and y-axis. So that is the reason we have to resolve this initial velocity into two components. One is along the x-axis, another one is along y-axis. Right. So now I will do that thing. Yes. Okay. Now I have one more thing. It is making an angle theta with this x-axis, right, projectile. So now what I will do, I will resolve u, that is initial velocity, into two components, right. First of all I will write here u means what? It is the initial velocity, right. So now u can be resolved into what? Two components, right. See, what are those two components? One is along y-axis, that is u. Just I will write u along y-axis is, velocity along y-axis is u sin theta. In similar way, another one is for which axis? X-axis. Then ux is equals to u cos theta. It means these two are the velocities along y-axis and x-axis. Right. So just I will write this thing here in this diagram. So for y-axis it is u sin theta, and similarly for the x-axis it is u cos theta. Right. Now we have resolved the velocity into two components. Next one is, and you always remember that the velocities along x-axis is always remains constant, but in case of y-axis, as you can see here, the velocity is changing, right. But in x-axis it is remains constant, but in y-axis you can see here, so it is changing. As by seeing the diagram only you can see that for the along y-axis it is changing. So if it is velocity is changing, then acceleration will act, and acceleration is that too, it is in downward direction, right. So here I will write the point, that is the acceleration for y-axis, right, which is ay is equals to what I have to write? Minus g, right. See, the object is coming downward direction. That is due to what? That is due to gravity, and it is downward direction. That's why I have written minus g. And similarly for the acceleration along x-axis is 0. Why? Because here the velocity is remains constant. That's why the acceleration is 0 for x-axis, right. And assume that somewhere the object come from this point, right. So here I will write p of x comma y, because it is in two dimensions, and this is what? Maximum height. This is what? Maximum height, and this is the position of the object, right. And one more thing you have to remember, that so it is starting with initial velocity. After certain height at this point, there the final velocity will be 0. Why? Because there is no distance and time, right. At a certain instant it will keep constant only. That's why the final velocity is 0 at a maximum height. It is reaching at a maximum height, there the velocity will not be formed. So that's why v is equals to 0, right. So I have got the thing. Just what I have done, I have taken the two axes, x-axis and y-axis, right. In that one I have thrown an object, so it is moving like this. It has been taken in this diagrammatic, right. So after that what we have done, we have resolved initial velocity into two components. Why? Because it is covering both x-axis and y-axis. So that's why we have resolved u into two components. One is along y-axis uy is equals to u sin theta, another one is ux, that is along x-axis u cos theta, right? And what I have told, in x-axis the velocity is always remains constant. That's why there will not be any kind of acceleration. But in case of y-axis, as you can see here, it is the velocity is changing. Right? The time and distance is changing. That's why the acceleration is along y-axis is minus g. Minus g, why I have written, that is downward direction. That's why ay is equals to minus g and ax equal to 0. Why? Because in x-axis there will be no acceleration. That's why ax equal to 0. Acceleration along x-axis is 0. Now, if we take the initial position as origin, right? So somewhere we have got the position of the object is p of x comma y at this position. So if we take the position of the object, if we take as the origin, right? If the position of the object is taken as origin, so what happens? If we taken the position of the object is taken as 0, that's x0 is equal to 0 and y0 is equals to 0. Right, if this is the case, and we will use the how much distance has been travelled along x-axis and y-axis, right? Using the equation, that is kinetic equations. Right, first for y-axis I will find. For y-axis, y is equals to uyt plus half ayt square. Right, initial velocity along y-axis, acceleration along y-axis. Right, see here y is equals to uy, we have here where yes u sin theta, y is q sin theta, and this is a t, you keep as it is, plus 1 by 2. Ay, what we have, ay is minus g. So in place of ay, what I have to put? Minus g. So it becomes 1 by 2 g t square. Right, so this is the equation number 1. See what we are doing here, we are getting the expression for the trajectory, that is a path followed by the projectile. Right, so similarly for the x-axis, what we will have, x is equals to uy. It was earlier case, now it is uxt, uxt plus half axt square. Right, is this clear? Yes. See here, next. Okay, see here, x is equals to uxt. Ux already we have here, ux is, there is a velocity, initial velocity along x-axis, which is u cos theta. In case of ux, it is u cos theta, and t you write as it is plus 1 by 2 axt square. So ax, what we have here, 0. So 0 means this whole term becomes what? 0. So directly I will write only this thing, x equal to u cos theta. Right. See here. So if I alter or if I rearrange some terms in this equation, that I can write in this way, t is equals to, you bring u cos theta to the arranged side, it becomes in numerator u cos theta. Right, you call this is the equation number 2. And in equation 1, what we have, u sin theta t minus 1 by 2 g t square. It means we have the t here, and from the equation 2 we have got the value for the t. So just Substitute the value of t in this equation number 1, or otherwise I will write put equation 2 in equation 1. So equation 1, first I will write that term y is equals to, so u sin theta you write as this u sin theta. See, in place of t, just only we have got which is u sin theta, right? In place of t, what we have, x divided by u cos theta, right? Minus 1 by 2, minus 1 by 2. So g you write as this, and what we have, t square, we have t, so squaring, it is x square u square cos square theta, right? See, y is equals to, see here u will get cancelled, sin theta by cos theta, it is tan theta, and x write as it is minus. So can I write this equation as 1 by 2 and write as it. So just g divided by u square cos square theta into x square. Can I write in this way? Of course I can write. See, now we have got the expression for the path, that means trajectory of a projectile. So in earlier case what I have told, parabola is always in the form of what? Y is equals to ax square plus bx square. So compare this equation with this. See, the same form we have, right? Ax, right? It is ax. See, ax plus bx square, right? So here also we have ax. In place of a, what we have? Tan theta. And in place of b, what we have? Minus g u square cos square theta and x square as it is, right? So this is what we call the expression for trajectory of a projectile, right? And just I will write the here a is 1. So just I am comparing with this equation with the original equation of the parabola, which is y is equals to ax plus bx square, right? See, x here we have, here also we have square, and x square also here we have, right? In place of a, what we have? Tan theta. In place of b, what we have? G divided by minus g divided by u square cos square theta, right? So now we have derived the equation for the trajectory of a projectile, right? Here a is what? Tan theta, right? B is minus g u square cos square theta. So this is the expression for the trajectory of a projectile. So now we will take some more statements that some more conditions that how much time it will take, right? And what is the time of flight? So that we will discuss, right? So we just take these things. Okay, now we will derive that how much time it has been taken to reach this maximum height. So now we have got all the theme of this projectile motion, that is projectile trajectory of a projectile, that what will be the equation when it covers the parabola direction. So that we have got now. So now it's time to get the how much time it will take to reach the maximum height. See, from this diagram you can see the maximum height only this, right? So now we are trying to get how much time it will take to reach this point. That is the maximum height. See the maximum height means it is only because of this y-axis. It means, I mean to say that we have to consider only y-axis, right? In x-axis it is always constant, so that's why we are not considering, but we are taking as a reference this x-axis, right? We have to focus only for this y-axis, right? By considering this only, we can get the maximum height. Now, how much time it will take to reach the maximum height, right? See here. So it has been started with the initial velocity, right? Initial velocity is what for the y-axis? you have to keep in your mind that we have to consider only the components of the y-axis, that is velocity, acceleration. Right. See here, it is starting with the initial velocity. The initial velocity is what? Initial velocity, it is, we are talking only about the y-axis, right? So u is equals to uy sine theta. This is the one thing. And after that, so the velocity is changing, right? Somewhere it is like this, it is in this point, in this point, in this point, right? The distance and time is changing. It means there will be a acceleration, and acceleration is due to gravity, that is acceleration along y-axis is minus g. Right, here we have two kinds, one is initial velocity, one is acceleration. Now after reaching one certain point, there the final velocity will be 0, right? So final velocity along y-axis will be 0. Right, now we have got the three parameters. Now I am trying to get the time. So using these three parameters, we have to use the equation which is v is equals to u plus at. Final velocity is equals to initial velocity plus acceleration. Right. So but what I will do, we are talking about y-axis. That's why vy is equals to uy plus at. Just now it is in the form of v is equals to u plus at. So vy is what? It is a 0. Why? Because the final velocity is 0. Is equals to uy is what? Uy is, sorry here, just uy is equals to, right, uy is equals to u sin theta. So uy is what? U sin theta, and a is what? Minus gt. Right, so bring minus gt to this side. So gt is equals to u sin theta. So what we have to get, there is a value of t. So t is equals to u sin theta divided by z. So this is the time taken to reach the maximum height. It means half of the trajectory, half of the projectile. So this we also call it as the time of ascent, and the time of descent is this. See, time of ascent is only from 0 to this point. Time of descent is from this point to this point. So that is time of descent, right? So this is one point we have got, that is a time taken to reach maximum height. So this much of time it will take to reach this maximum height, right? Now we will find the time of flight. Time of flight is nothing but it is the double of the time of ascent, right? So the second point here we have time of flight. Okay, time of flight. So it is represented by t. It is always equal to 2t. So 2t is u sin theta divided by z. So the first point, this is the second point. So another 2 points we have. So first you take these 2 points. After that we will go to the third and fourth. Okay, third one here, the maximum height of the projectile. So in earlier 2 cases we have found the how much time it will take to reach the maximum height. But now we will find out the how much, right? Sorry, the maximum height of this projectile. So this thing we need to find out here. So again, to find this one, again we have to concentrate only for the y-axis. That is the component of the y-axis. So we have got the components of y-axis. One is initial velocity, which is u y is equal to initial velocity is what? U sin theta. Another one is acceleration, is minus g. So these 2 things, and final velocity along y-axis is 0. And one more we have got time taken to reach the maximum height. So just only we have got, which is t is equals to what we have got, t is equals to u sin theta by g. u sine theta by z. So now what we have to find out? The maximum height. So using the equation Vy is equals to Uy t plus of a t square of ay t square. Right. Using this equation, so Vy, that is the final velocity. Right. Yes, we will take this as the height. Why? Because we are trying to find out the height. So h is equals to uy. Where we have uy is u sine theta, and t is what? U sine theta divided by g. Okay, ay is what? Minus j. So just minus 1 by 2. Ay is what? G. And t again. T is again this one. But here square is there. So just make a square to every. So u square sin square theta divided by g square. So you solve this equation by taking LCM and everything. So finally you are going to get u square sin square theta divided by 2g. Right. U square sin square theta divided by 2g. So by taking the LCM, you can solve. So this is the maximum height of the projectile. Right. First, what we have got? We have got the trajectory of a projectile. After that, how much time it will take, and after that, maximum height of the projectile, and after that, time of flight. So these are the things which we have done in this class. Right. So in the next class, the last concept is left, which is uniform circular motion and derivation for the centripetal exertion. So we will discuss in the next class. So until then, thank you.